Hello everyone, this is Permeable Pavement Group A. Today our topic is maintenance of permeable pavement in tropical climate. So why do we need permeable pavements? For urban areas, stormwater runoff is an annoying problem, especially for tropical regions. However, permeable pavement can solve this problem, as shown in Figure 1. The main function of permeable pavement is to reduce stormwater runoff volume and decrease the peak flow rate to prevent flooding. Also, it allows stormwater to infiltrate underground and recharge the groundwater. Since permeable pavement is just a remodeling of traditional pavements, there is no need for extra space, which can relieve the land storage problem in urban areas. Today, we will compare different kinds of maintenance methods and provide some reliable methods to solve the clogging problem of permeable pavement in tropical areas. First, let's talk about how to design a permeable pavement. The permeable pavement system is a stormwater management that controls sediments. As shown in Figure 2, permeable pavements consist of a permeable surface layer, choker courses, and other sublayers. Currently, 5 permeable pavement types are widely used, as shown in the table, including porous asphalt, permeable concrete, and so on. The design of the permeable pavement system is mainly based on the required capacity of green infrastructure and the treatment goals for higher stormwater storage and better water quality treatment.
But permeable pavement systems are prone to clogging due to the accumulation of sediments. Here are three factors that affect the clogging. So the first is the type of sediments. It is reported that finer particles are likely to cause more clogging than coarse particles, because finer particles tend to fill within the permeable pavements, resulting in a denser and less permeable upper layer. The second is the age of permeable pavements. Shown in Figure 3, the infiltration rate decreases significantly within the first 2 to 3 years, and the general trend is the infiltration rate decreases as the age increases. The last is the local climatic conditions like the rainfall intensity. The lifespan of permeable pavements in arid areas is longer than that in the wet areas. In addition, larger rainfall intensity may lead to an increase in fallen leaves on the ground, which is worsened by stormwater that can break them down into final particles. So, we need to better understand the clogging mechanisms and maintenance methods in tropical areas. So, for permeable pavements in tropics, they are different because of the more severe flooding problems and scarcity of land resources. First, it needs to have a higher surface infiltration capacity because there is frequent short-term and high-intensity rainfall. Permeable concrete pavers with more open-air voids are proved to have the larger infiltration rates, so it might be more suitable for tropical regions. The drainage effects are shown in Figure 4. Also, it is supposed to have a higher water storage capacity. Despite the heavy rainfall, tropical regions still lack water resources. Shown in Figure 5, permeable pavements with raised outlets or larger reservoirs or underdrain are better to store more water that can be reused for irrigation. To further save the land, they can be connected with retention ponds. Besides, clogging-resistant materials are more desirable because the sediments are more easily washed into the pores under higher rainfall intensity. Shown in Figure 6, the use of larger-sized materials in the surface layer or the use of sediment traps or additional pipes for drainage may decrease clogging.
Hi, this is Miao. I will continue to introduce about the maintenance methods. In order to ensure good conditions of permeable pavements, maintenance methods as a function of PP types are necessary. Nowadays, mechanical swapping, regenerative air chucks, vacuum swapping, and pressure washing are commonly used to solve the clogging problems in pavements. To compare the effectiveness of different methods, many researchers have done a lot of lab or field tests. For example, Ballas was among the earliest researchers to test practical cleaning treatments on PICPs. He noted that as clogging becomes more serious, more intensive cleaning methods are required, and pressure washing is an effective method for preventative treatment. Corporal's study conducted field tests with a vacuum truck on 3 types of permeable pavement which had been artificially clogged. The study showed that vacuum swapping could restore some permeability, and the effectiveness of maintenance is affected by the type of PP. Next, let's briefly discuss the suitable maintenance methods in tropical climates. Porous concrete is recommended in tropical regions for its high infiltration rate. Common maintenance methods for PC are vacuum swapping, pressure washing, and power washing. Among them, vacuum swapping is the preferred option with high recovery efficiency. However, since most tropical regions are small island developing states or underdeveloped states, the expensive vacuum swapping trucks may not be readily available in these regions, and PC is thus not recommended for application. Other studies proposed the alternative use of paver blocks in tropical regions, as this PP type requires cheaper maintenance options, such as removal and replacement of the infill material. In conclusion, in this project, we summarized multiple studies to evaluate which method is best for the maintenance of permeable pavements in tropics. Results show that the type of sediment, age of permeable pavement, and local climatic conditions can affect the clogging, and the permeable pavements applied in the tropics are supposed to have a higher infiltration rate, higher water storage capacity, and longer service life to better address the severe flooding problems. Paver block is a suitable choice for tropical regions because of its cheap maintenance cost. Additional research into the life cycle cost analysis of different PP types in tropics are highly recommended. These are some references for our project. That's it, and thank you, Professor Mahanti, for your help and instructions. Thank you for listening.